Today we're going to graph absolute values. Looking at the examples here, you're going to focus on the sign that's in front of your A. So if it's positive, then your absolute value graph is going to be a upward facing V-shaped graph. And if it is a negative, then it's going to be a downward V-shaped graph, which is reflecting vertically over the x-axis. So looking at number one, and also just to backtrack, when you're looking at your transformations, we still have A, H, and K as we have had in like logs, exponents, square roots, and cube roots. But you're wanting to focus on your HK, which is your vertex, if you choose to just manually use the second example method that I'm going to use, which is using your slope. It's helpful to know how to identify your vertex. For example one, though, we're going to use the calculator. Let's go to our calculator here, and I'm going to go ahead and clear out. I was in here putting things in already. So let's go ahead and type in -1/3. Negative is down by the enter button, 1 divided by 3. In order to get absolute value, press math, scroll to the right where it says num, and then number 1 is your absolute value. And then we're going to type in x plus 2. Arrow over, plus 6. So what I want to do is go to my table, which is second graph, and I want to look for that vertex. So that's why also it's helpful to even know that HK is your vertex, HK. However, H, the sign is changed because you're really looking for what would make, if I put a number here, what would make this equal 0? So the number I would have to put in the place of X would be -2. So I'm going to look for -2, and I see that, yes, it is in fact -6 for my vertex. So that's good to know. I'm going to go ahead and write that down. -2, +6. So I'm going to go ahead and plot that point, and -2, +6. And I know that my graph is going to go downward because there's a negative leading coefficient, basically. So what I want to do is go to my table, and I can just, for this example, I can just use anything that has a whole number. So I have 1 and 5. Let me make sure I'm actually, yeah. So 1 and 5, and I have 4 and 4. I'm just looking at the whole number, 7 and 3. And then in the next example, I'm going to show you how to use your slope. You also want to go on the opposite side. So we have -5 and 5. -8 and 4. And -11 and 3. Now, what you should notice is that the graph is symmetric, meaning that I'm seeing the same y value when it's symmetric. So y is the same here, here, and here. So what I'm going to do is just go ahead and connect my points to make my graph. Let's see here. And at the end of my graph, I definitely want to make sure that I use arrows. Okay. So that's not perfect, but you understand it's going to be an upside down V because, again, the leading coefficient. So my x-intercept is kind of hard to tell because on my coordinate plane, you can't see where it's actually crossing the x-axis. So that's where the calculator comes in handy. So I go to my calculator, and what I'm going to do is, just so you can see what the graph does look like, I'm going to go to second trace. Another word for x-intercept is 0. So I'm going to choose number 2. And it asks me at the bottom, left bound. So that means any place that is before, if I'm reading from left to right, it's going to be under, in this case, under my x-axis. But as you can see, I can't see where it's crossing my x-axis. So that tells me I'm going to have to adjust my window. To the left, I just want something, I don't know, I'm just going to put -25. Left means men, where, X men. And if I wanted to see more to the right, then I would go to X max. So again, I'm just going to put a random number and I just keep looking to see. Now I can see where it's crossing my X axis. So let's do this again. Second, trace and go to 0. And where it says left bound, I'm using my left and my right arrows only, not my up and down. So anywhere below where I'm trying to actually find my value, which is on the X axis, I can just go below anywhere and click enter. Now I want to go, it asked me about right bound. So I want to go anywhere above where I'm looking for an answer or a value and hit enter 2 times. It will tell me that my 0 is located at -20 and 0. So I'm going to go ahead and write that down for my x-intercept because again, 0 does mean x-intercept. I notice I have 2 though. So I'm going to have to go to second, trace again, hit 2. And now this time, if I'm going left bound for the opposite side, I can actually just go anywhere above the x-axis. So right here is fine. Anywhere below when it says right bound. So I'm basically trying to create an interval between where before and after where I'm trying to find a value. Enter, enter. So now this time to the right, my 0 falls between where x is 16 and my y is 0. So going back here, so I'm going to write and 16 and 0. So those are my 2 x-intercepts that you can't see with how I manually drew it in. Now my y-intercept, you can see it, but you can't tell exactly what it is. So again, let's go to our calculator. Going to the calculator, it says second, trace. You want to choose number 1 this time because it's going to ask you what value do you want for x? Well, for your y-intercept, x has to be 0. Hit enter. So when x is 0, y is 5.33. So that's why it was kind of hard for us to see it just looking at it. For my y-intercept, when x is 0, y is 5.33. My domain will always be all real numbers when I am talking about absolute value because it has arrows that can go from left to right. When I am referring to my range, I've already notated on here, it goes from bottom to top, negative infinity to positive infinity. So what I do is I start from the bottom and I stop at y because range means my y values at the top of my graph. So here is actually 6. Another place you can look is your vertex. Your vertex tells you your y value is 6. And since it's upside down, that means that's my highest value. So I can go anywhere from negative infinity to 6. My interval of increase means my x values. So everything that can fit in my graph that goes from negative infinity to positive infinity. Let's just write that down somewhere. Intervals means your x values. Where is it increasing? My graph is increasing from this point. So on my x value, x-axis, that's negative infinity. And where does it stop? Again, if you're not clear, look at your vertex, your x value though. So it's going from negative infinity up to -2 in terms of increasing. Negative infinity to -2. Now for my intervals of increase and decrease, I'm using parentheses. I apologize, a few minutes ago, I forgot to tell you, for a range, you would use a bracket if that point is actually included in your graph, and it is, so 6 is included. For my intervals, I'm using parentheses though. So my interval of decrease, that's going down. However, I'm looking at my x values. Well, if my x value was increasing at -2, it then transitioned and started decreasing at that same -2. But this time my arrow is going to the right. So therefore, I'm going from -2 to positive infinity for my decrease. My positive interval, again, is taking into account everything between negative infinity to positive infinity. So I have to keep up with that. So if I'm looking at my graph, I can see, and it's going to be helpful to know your x-intercept, especially if your graph looks like mine, because you can't really see where it's crossing the x-axis on this graph. Even if I drew a line here, you can't really tell what the value is. So that's where the x-intercept comes in handy. So I know that anywhere from negative infinity up to negative 20, which is my first x-intercept, I am going to have a negative interval. What does that mean? Anything that falls below my x-axis. So that's what that means. Anything that's falling below. So when I'm writing that out, I am going to write for my negative interval in parentheses, negative parentheses to my first x-intercept, which is negative 20. I actually have another negative interval if I wanted to go ahead and make note of that. This part that's under the x-axis. And now I'm looking at my second x-intercept. I think I said interval, x-intercept. And that's going to be at 16. And my graph goes on forever towards positive infinity. Now let's go back to our positive interval. Well, that means everything that is above my x-axis. So all of this portion right here. So what part of my x-axis falls in between that? Well, again, it's looking at my x-intercept. It's going to be from negative 20 all the way to positive 16. And if I'm paying attention, I will see that I did account for everything from negative infinity to positive infinity. And then I saw negative 20 and negative 20 two times, and I saw 16 and 16 two times. So I know I'm on the right track. My end behavior is going to be the same for both of my blanks because I'm looking at the arrows. It doesn't matter if x is going to the left or if x is going to the right. What ends up happening with my arrows at the end of my graphs on both sides? Well, they're both going down. Down for y means negative infinity. So both of these will be negative infinity. That's the first example when we're using a calculator. So let's use this second example. And I may still use the calculator for this one, but I do want to show you how to use the slope just in case. All right, so for this one, again, I'm looking at h and k. I'm identifying my vertex. So that is going to be 5, negative 4. So notice I'm only changing the sign for h, not for k. And that just tells me what would x have to be to make that equal 0? So it would have to be a positive 5. That's why we use positive 5 here. So I'm going to go ahead and plot that 5 and negative 4. And now that I know that I can use the slope option as well, I'm just going to identify my slope, which is 2 over 1. And slope means rise over run. Both of those are positive because there's not a negative sign in front of that. So I know that my graph is going to be a V is going to face upward. So from my vertex, I'm going to rise 2 and run 1. Rise 2, run 1. Same thing, just keep going as much as you want to. And then over to the left, I'm going to do the same thing because it's symmetric. Rise 2, 1, rise 2, 1, rise 2, 1, so on, so forth. Now, if I just get a ruler, hopefully mine will cooperate. It's been acting up today. Okay, it's not cooperating, so I'll just try to use a manual ruler. And that's not working either. There we go. You understand what I'm trying to do. All right, so, and now you want to go ahead and put your arrows on there. I apologize. Okay, so now what I want to do is I want to answer my questions with my x-intercept. I can see that it's clearly at 3 and 0. And it's also at 7 and 0. But again, if you wanted to verify this, which there is nothing wrong with verifying, just go to your calculator. And once you go to your calculator, go to y equals, clear out anything that's there and go ahead and go to your absolute value, which we're going to go to num1 here. And it was x minus 5, arrow over negative 4 or minus 4. And now you can go to your table, second graph. And if you don't like those numbers, you can change your table. So we wanted to look at the vertex 5, -4. So go down to where it's 5 on your calculator. And what I typically do is go 2 numbers up above and then 2 numbers below, especially if I'm manually creating a table. So I have 3 and 0, that is true, and 4 and -2, that's true. So looking at my x-intercept, 3 and 0 was one of the ones I said, and 7 and 0, so that was correct. Y-intercept, where is x0? So you can either go here on your table, or which is 0, 6, or you can go to second trace, hit value, and it's going to ask you, well, what is x? What's the value of x? You just tell it 0. And now it will tell you that your y-intercept is going to be 6 when x is 0. So when x is 0, y is 6. I already said domain is always all real numbers. And my range this time going from bottom to top. My range is going to be the same as my vertex y. So my y is -4, and I know I'm going upward, so it's going to be in a bracket -4 to positive infinity, and that has a parentheses after it. Let's see, my interval of increase, I'm looking at my x values. Where am I increasing? I'm increasing from this point on my graph right here. But if I'm looking at that, I want to go back to my vertex and look at my x value, which is 5. So I'm increasing from 5 to positive, 5 to positive infinity. And this is going to be in parentheses. My interval of decrease, again, I'm going from negative infinity, and I just want to keep going to that same 5, negative infinity to 5, because I'm only looking at my x values. The positive intervals, that is everything that's above my x-axis. I have to account for everything from negative infinity to positive infinity. So from negative infinity to +3, because I'm looking at my x-intercept now, I'm going to have a positive interval. Negative infinity to +3. And I see on the other side, I'm also going to have another positive. So I'm just going to go ahead and write my union. Because again, I have to account for everything between negative infinity to positive infinity. So what is that? I'm going to go to my second x-intercept, which is 7. And it's going to go on forever to positive infinity. Now for my negative infinity intervals, negative intervals. Try to use a different color here. This little portion that's under my x-axis is going to be my x-intercepts, 3 to 7. My end behavior, I'm looking at what's going on with those arrows. Are they going up towards positive infinity for y or down towards negative infinity? They're both going up. So positive infinity for both of these blanks. So you have learned how to graph absolute values. If the leading coefficient is positive, it will be going upward and looks like a V. If it's negative, it will go down. Have a great one. Don't forget to subscribe and like the video.